method for dividing polynomials, and that is using synthetic division. Now, synthetic division is a little easier, but it does have a few handicaps in that it only works if you're dividing by a linear factor. And what I mean by that is if you have x minus a, where a is any number, or I could have x plus a, but those are your linear factors. You have to divide by just a linear. So before, when I divided by the quadratic, I couldn't have used synthetic division. I had to use long division on that. But if you have a factor of this form, you're going to set it equal to 0 and solve it. So if I have x minus a, when I add a to both sides, that will give me x equals positive a. So x minus a as a factor is the same as x equals a as a 0. Or vice versa, if I have x plus a as a factor, I'm going to subtract a from both sides, and that will give me x equals negative a. So x plus a as a factor is the opposite sign as a 0 because you're moving it to the other side. So let's look at this first example. Again, you need to make sure you're in descending order and that there's no missing terms. If there is, you're going to put a 0 place order. But what we do here is we take the coefficients of each term, and we're good because we've got x cubed, x squared, x, and then the constant. We're going to pull down those coefficients and leave a little space between them so you know that they're separated. And we're going to draw like an upside down, a big upside down division sign. And then we're going to take our linear factor and solve it for x to get the 0. So x minus 2 as a factor is x equals 2. That 2 goes outside your box. That's what we're dividing by. So this is how synthetic division works. You pull the first coefficient down and write it underneath, and then you multiply 2 times 6. And that goes in this next spot under your next coefficient. So 2 times 6 is 12. We're going to line it up under the negative 19, and then you're going to add. You're going to add every time. So negative 19 plus 12 will give me a negative 7. And then I'm going to repeat the process. 2 times negative 7, and put that answer right here. So 2 times negative 7 will be negative 14. And then I'm going to add again. So 16 plus a negative 14 will give me 2. Then multiply again, 2 times 2, and put that answer in the next spot. So I've got 4, and then I'm going to add one more time, and I get 0. Now the last number is your remainder, so put a little box around it so you know it's the remainder. So I've got 6, negative 7, and 2. What those are is those are the coefficients of your answer. So what I've done here is I've taken a third degree polynomial and factored out a linear term. So I've factored an x out of an x cubed, which is going to leave me a 2 degree or a quadratic. So my answer is going to be 6x squared minus 7x plus 2. And that's because I started with a third degree and took out a linear factor. Now notice my remainder is 0, so I'm not adding or subtracting anything. So this is my quotient or my answer when I've factored out an x minus 2. So a couple things here. If you have 0 remainder, that means that x equals 2 is a 0 of your original polynomial because you had a remainder of 0. So if it comes out, that's an actual factor, or it evenly divides into it. So if I graph that, I'd have an x-intercept at x equals 2. So also another thing, if there's no remainder, if I take my divisor or my factor and multiply it by 6x squared minus 7x plus 2, you will get back your original dividend. So that's just a couple things to keep in mind as we move on. Let's do a little more practice. Notice here I've got an x to the fourth and then it jumps to x squared. So I need to have a 0x cubed placeholder. Don't forget that or it will mess up your entire answer. So now I'm going to pull my coefficients. I'm going to have, well, let me write this out so it's a little more organized. So I've got an x to the fourth plus a 0x cubed minus 10x squared minus 2x plus 4. That's my f of x, or my dividend. I'm going to take the coefficients 1, 0, negative 10, negative 2, and 4. And I'm going to draw my half box. And I'm dividing by x plus 3. So as a 0, that's going to be x equals negative 3. So I'm going to put the negative 3 out here. And then you bring the first coefficient down, multiply. Negative 3 times 1 is negative 3. Add 0 plus negative 3 is negative 3. Multiply. Negative 3 times negative 3 is positive 9. Line that up underneath and then add again. That's going to give me a negative 1. So negative 3 times negative 1 is positive 3. Add again. And that'll give me 1. Multiply. And then add again will give me 1. That's my remainder. So here I started with a fourth root, or a fourth degree, and I factored out a linear term. So that means this is going to be a third degree. So this is going to be 1x cubed, or just x cubed, minus 3x squared, minus 1x, plus 1. So you just put those as the coefficients in descending order. This time, though, I have a remainder of 1, so I'm going to have plus 1 over x plus 3, my original factor. So now this is the answer after I do synthetic division. Okay, let's look at the next example. Check it, make sure you're in descending order and there's no missing terms. This one's good. So I'm going to have 3, 8, 5, and negative 7. And notice here, it's already solved for x, so you go ahead and put the negative 2 there. So just watch that. If it's already x equals, you just are dividing by that number. So I'm going to pull the 3 down, multiply, add, multiply, add, multiply, add. So now I started with a cubic, I factored out a linear, so I've got a 3x squared after I've factored out 1x, 3x squared plus 2x plus 1 with a remainder of negative 9, and you can do minus 9 over x plus 2, because remember you got to turn that back into a factor, or you can do plus a negative 9 over x plus 2. It doesn't matter. Both of those are the equivalent. So that's your answer there. Now let's take a look at the remainder theorem. Notice from the previous example, if I was to find f of 2, or f of negative 2, which means I'm plugging in negative 2 in for x, let's see what happens. We've got 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. So I've just plugged in -2 everywhere there was an x in my original. That's going to give me 3 times -8 plus 8 times +4. Let's go ahead and do this. That's a minus 10 minus 7. So that's going to give me a -24 plus 32 minus 10 minus 7 will give me -9 when I add all of that together. Notice that that is the same as our remainder. So this is the remainder from above. Which brings us to the remainder theorem. The remainder theorem says that f of a is equal to the remainder when using synthetic division. So what that means is I can pick any x. So if I wanted to say x equals 9, I could use synthetic division with the 9 out to the side, and whatever my remainder is would be equal to f of 9. So I want you to listen very carefully. If on a homework assignment or a test, if it says use the remainder theorem in synthetic division, I want you to use synthetic division to find the remainder. Now, I don't care if you come down to at the bottom and check it by plugging it in. But if it says use synthetic division and the remainder theorem, I want to see synthetic division and the remainder. You will not get credit for your answer if you just plug it right in for x. That's I know you know how to do that. I want to see that you know what the remainder theorem says, and that's that the remainder is equal to f of whatever you're dividing by. So just remember that. You'll have that on your homework and on a quiz and on your test. I have to see the synthetic division for you to receive credit. Okay, moving on, we're going to be finding zeros and the complete factorization. This is still synthetic division. So here we've got x cubed minus 7x plus 6. Notice we're missing a x squared, so we're going to put a 0x squared placeholder in there. So when I bring down my coefficients, I'm going to have a 1, 0, -7, and a 6. And then I'm dividing by x minus 2. So that's going to, when I solve that, will give me x equals 2. So I'm going to put a +2 on the outside. So I'm going to use my synthetic division, bring down the 1, multiply, add, multiply, add, multiply, add. Now here, if you get 0 as a remainder, that means that x minus 2 is a factor or a 0 of that function. So it evenly divides into it. Don't forget about that x minus 2 when we go and do the complete factorization. So we started with a cubed. So the coefficients here are x squared plus 2x minus 3. Now that's a quadratic that I can factor. That'll actually factor pretty easily into x. And I'm going to have a +3 and a -1 to get that 2x in the middle, the positive 2x. So that's that quadratic factored. And then remember, we've got the x minus 2 that had a remainder of 0. So that is also a factor. So x minus 2, the one you divided into, and then your quotient gives you your complete factorization. And then it also wanted us to find all the zeros. So this is where you set each one equal to 0. So I'm going to have x equals 2, x equals -3, and x equals 1. Those are your zeros of your function. And remember, zeros are the same thing as solutions, roots, or x-intercepts. So let's do that again. This one says find all the zeros of 3x cubed plus 2x squared minus 19x plus 6 that has factors of x minus 2 and x plus 3. So this one has given us two factors to start with. Notice that we're in descending order and there's no missing terms. So I can just pull my coefficients without putting any placeholders. And let's start with x minus 2. So I'm going to have a x equals 2 on the outside. So I'm going to bring the 3 down, multiply, add, multiply, add, multiply, add. And they told us they were factors, so your remainder needs to be 0. If it's not 0, you did some of your math wrong somewhere. Now, what you could do here is start over from the beginning with your same coefficients and divide out the -3. But if this was a factor, I can just go ahead and do the next one from the answer after I've divided the one factor out of it. So this one gives me a quadratic of 3x squared plus 8x minus 3. And then since x plus 3 is also a factor, I can just continue on with that answer, and it'll actually make your work a little less because you don't have this. Will, once I factor another linear factor out of this quadratic, I'm going to be left with just another linear answer. So now this one, I've got a remainder of 0, and this one that I've factored out another linear term will leave me with 3x minus 1 with this from this answer. So my factors would be x minus 2 that I started with, the x plus 3 that I factored out second, and then the last answer was a linear factor of 3x minus 1. So that's my complete factorization. And then if I want my zeros, I just set each of these equal to 0. And this one would be a positive 1/3. So my 3 zeros are 2, 3, and 1/3. Okay, let's look at one more. This one's a little bigger, but I've still given you two factors to start with. So check and make sure you're not missing any terms and it's in order. So we're good. We can pull our coefficients. And we're going to divide by our first factor, which will, when you solve it for 0, gives you a positive 2. Bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add. And I'm good. I got my 0 remainder, which I should because I am given it is a known 0. Notice I started with a fourth root or fourth degree. So this answer, sorry, not that 0, but this answer would be a third degree. So I'd have 2x cubed plus 11x squared plus 18x plus 9. But since I'm given another 0, I'm just going to add on to that. And from that answer, divide by the -3. So multiply, add, multiply, add, multiply, add. And so this is a quadratic once I've factored out another linear factor. So I've got 2x squared plus 5x plus 3. And then I also had the x minus 2 that I originally factored out, and the x plus 3 was the other factor. My quadratic, you can factor it. That's going to be, I'd have to put the 1 here and a 3 there to get the 5x in the middle. And if you're having trouble factoring, you can just guess and check, or you can do the other method where you do it by grouping that we learned in the first chapter. So whichever's easier. This one's actually pretty easy to factor. So this is my complete factorization when I have it down to all linear terms. And then if it asks for the zeros, you're going to set each equal to 0. So the first one would give me a -3/2. The second one would give me a -1. I've got a +2 and a -2. Oh, sorry, that should be a 3 at the end. So a -3. So those are your 4 zeros of your polynomial. So this just takes practice. I said multiply, add, probably 50 times. I just wanted you to get that sunk into your head. Just be aware of the difference between when they say a factor and a 0, and just be very careful, just like with long division. Be careful with your signs, and if it's in order and you need placeholders. If you get something wrong on your homework, check that first, because that's usually the problem. And let me know if you have any questions.